Characteristics of sound waves. Now we'll discuss different characteristics of sound waves such as amplitude, frequency, velocity, pitch, loudness, intensity. All these terms, they are very important to understand the sound wave. Okay. See, a sound wave can be described by its frequency, amplitude and speed. What is the meaning of these terms, frequency, amplitude and speed? We'll have a great discussion over it. Okay. Now see, the figure below represents the density variation. So we have already discussed when the wave is in the compressed form, the particles are close to each other, and when they are close to each other, the spacing between them is very less, they are densely packed, right? Just recall the example of your lunch break and the case of your examination room. In lunch break, you people are very close to each other, right? You're sitting together, you're eating your lunch, sharing your lunch, so you're close to each other because it's easier to eat that way. But when you are in the examination hall, you are separated by a certain distance with respect to your classmate or your friend, right? So that is the case of rarefaction in your examination hall. In the lunch break, you people are in the compressed form. So that is why here in the compression, the particles are close together, so their density is more. Density means how many particles are there in one volume, in one unit of volume. So here we have large number of particles in a unit volume. In the case of rarefaction, we have less particles. Suppose here we have 100 particles in this volume, but in rarefaction we have 10 particles. So density of compression is more, density of rarefaction is less. So this shows the density variation in the sound wave. Then this figure represents the pressure variation. In compression, the pressure is very high because lot of particles are there, right? And in rarefaction, see, in compression, high pressure. In rarefaction, we have low pressure. Okay, so this shows the pressure variation. Now, look at this diagram. This is a representation of density of pressure. Now, when the upper portion, which is also called crest, okay, this represents high density which means compression. High density, or you can say high pressure. So this upper part represents compression, but the lower part, trough, it represents rarefaction. This represents the rarefaction. So rarefaction means low pressure, or you can say low density. Okay. This is crest, this is trough. So the sound wave is shown in the figure below. The figure shows how the density and pressure change when the sound wave moves in the medium, right? So in the starting portion it is showing compression, then after a certain time it is showing rarefaction. Okay, so on and so forth. Now see, very important term, the distance. Now we are talking about wavelength, very important term. Okay, see, wavelength, length means we are talking about distance. So always keep in mind, when you are talking about wavelength, we are talking about some sort of distance. Okay, now see, the distance between two consecutive compressions or two consecutive rarefaction is called wavelength. The wavelength is usually represented by lambda. Just be very thorough with the symbols. Lambda is the symbol for your wavelength. This is how we draw lambda for wavelength. It's a Greek letter lambda. Now since we've discussed that it is the distance between compression, two consecutive compression or two consecutive rarefaction, that means distance is measured in meters. So SI units of wavelength will be meters. Okay. Now with the help of the figure, let us understand. See, the upper portion, upper part, crest part represents the compression. So these are the two consecutive compression. Therefore, this distance becomes your lambda. Also, you can take the distance between two consecutive rarefaction. Rarefaction is shown by trough, so first and second. So, two consecutive rarefaction, that means this distance is your lambda. You can take another example. This is another. This also shows compression. This distance will become your lambda. Okay. So, I hope you are clear with the concept of wavelength.